So good afternoon, good morning, and potentially good evening. My name is Timothy Gergis. I'm the product manager for model assembly and morphing. And today we're going to be going through, alongside with Greg Nunn, who's the director of product management for model build. We're going through the new additions for the connector workflows and the parts and subsystem workflows. So the agenda for today, general improvements for the model assembly, so the connector workflows, a new type of realization that we've introduced specifically for Hyperlife. We'll be discussing scenarios. So what is the scenario entity and how does that work and help with your model assembly workflows? Greg will then be discussing the part assembly organization, subsystem representations, and then, Greg, one of them was subsystem hierarchy, wasn't it? I made a mistake. Sorry about that. I think it was subsystem representation, and the last one's supposed to say subsystem hierarchy. Sorry about that. That's my mistake. So we jump in. So the general improvements. So this is just going to cover some general improvements that we've introduced into connectors for 2022.2. And this continues the workflow and the process of PostScript removal that we've kind of been chasing for the last few years, effectively to get to an endpoint of no PostScripts in the product, and then also allow the customers to have customization and specialization of their realizations based off of the core connector realizations. So you'll no longer see no skip / PostScript / user PostScript or customize or no PostScript. What you'll see now will be you have the option in the property material creation where you can select whether you want a single or per connector or whatever. You can now have the option of script only. This will run the legacy PostScript behaviors. If you have historically set up your connectors with the PostScript described in the FE config, it will just appear as script only, and there should be absolutely no difference to your realization. So from a carryover perspective, that should remain as it currently stands. Moving forward, however, you can describe now a customization script, as you can see here, in any of our realizations that will allow you to then run a script at the end of the realization of the connector. What this can mean is for things like SimQuad LTB or other different realization types. If you want to add a pretension, if you want to create sets for your heat affected materials, or anything you want to do from a customization point of view that might not necessarily want to go through core, but might want to be something that your customer is explicitly asking for, the customization script allows you to get a full and complete realization, including things like contacts, including all of the other creation things that, including all of the other things that you would normally and ordinarily get out of the connector realization. You can now get that without having to script the whole thing. So it's really just a way of allowing you to automate the end tasks that you do post connector creation. So it's available on all realizations now rather than just a small subset. So this is really closing the and sort of closing the loop on the difference between the old type of realizations, the new type of realizations, what was historically PostScripts, what was historically this. This is kind of really now leveling out and finally enabling, sort of from a functionality point of view, across a broad spectrum, how you would go through the process of customizing and editing all of your connectors kind of from that perspective. So unless you specifically go via customization script, then you shouldn't see any real difference for those who still have legacy PostScripts defined in the FE config file. The next one is the last of the connector panels has been removed. So the last panel was the quality connector quality panel that has now been migrated to a controller. So the functionality still exists, but the panel is no longer available in HyperWorks. The panels, none of the connector panels should no longer be available in HyperWorks. In the process of the panel removal for the connector quality, we are now investigating and doing further expansions on improving the performance of it as well. So there's it's the old quality panel was quite limited, and we're now working on improving that, hopefully for future releases. So in the future releases, if you wanted to do comparisons between connector lines, which you don't support, that should be coming. Attachments should be coming. There should be further enhancements coming for this. This was just kind of the first step of the refactor, but it's now officially gone. So that's good news. In bigger news for the heavy industry, and most customers actually who use seam cord LTB, as well as the stitch connectors, we now finally support cross support for stitch connectors. So if you have two overlapping imprinted connectors, so in this case, I'm going to create a series of 3 connectors, and I'm going to create them independently. And then the only requirement to this is you realize them simultaneously. So it can do all of the cross imprinting together. So in this case, historically, this would have failed around those crossed over edges. And now we end up with a fully imprinted, fully realized, fully crossed support for all of our stitch connectors. This historically wasn't available before. This has been one of the main weaknesses of the seam cord LTB. So it's really good to see this finally in the product and available in a more direct and easier to use manner. The only requirement here is you realize everything simultaneously. We are trying to think of a way of removing that requirement, but for the moment, this is the only requirement that kind of sits in the way of this. The last thing is probably the biggest and most important thing that from a model assembly and model build workflow is the scenario managers, scenario manager. So scenario manager is a way of essentially automating the application of controls to engineering entities in a robust and repeatable manner. So the intention here, now at the moment, it's only exposed for attachments and connectors. They're the first real run through on this. So I get the honor of presenting it. But other engineering entities like the loads, contacts, that sort of thing, they will then be picking this up. They'll then be picking this up and running this through. So how this works, I've got a really quick video that kind of demonstrates the workflow here. So we launch Scenario Manager. I assign a control that I want to be applied. So in this case, it's an OptiStruct spot weld type realization. I generate a rule. I can specify this by information. I can select explicitly all of them. I can filter. You can create rules. So in this case, I just want all of my spot connectors to get a particular realization type. I want all my line connectors to get a particular realization type. In this case, you can see the count will illustrate how many of those connectors fall within that boundary. Now I can rename this to any name that is of use for the customer. We can duplicate it. In this case, I wanted to set it up for crash. I can then change my solver interface to a new solver interface. So in this case, it's going to be for LS data. I select a control for that particular solver profile. And I select the next control for the next solver profile. Now, I'm going to create a new rule, a new definition. In this case, I've got a more detailed realization that I want to apply to a subset of these connectors. So I'm going to create a new rule. I'm going to specify data is what I'm interested in. I'm looking for metadata on the connector that is a function load path. So what this means is it looks for HM metadata that sits on a particular entity and then is trying to pick that up as a rule. Now, if I jump back very quickly, you can see that the count jumps and is removed from the top count. What that means is the scenario manager is very dependent on the order. It means that the count, the higher the rule, if a connector meets or an entity meets that rule, then it's not going to be used for the next one. So once I've defined my rules and got that set up, I can optionally realize the connectors and I can hit apply. And what this will do is it will take the rules, it will take the controls, it will apply them to the engineering entities, in this case connectors. It will realize them. I can see in my load paths, I get a heat affected zone realization. Outside of my load paths, I don't. I need to change the solver profile so it's soft converted to to crash. If I now go to MVH, it prompts me to change back into OptiStruct because it knows the scenario that I'm trying to apply is in OptiStruct. It applies, converts it, solver profile, unrealizes the connectors, reapplies a new control, and then applies and realizes. So this is kind of the last piece, the capstone of the model assembly from a connector perspective workflow, where we really tried to make sure that you can repeatably and robustly apply controls to your connectors and attachments. In this case, we can now automate the application of those robustly through the process. So you could save your scenarios that can be unloaded, loaded into a new session, and repeatedly reused. So if you're with the improvements that came in 2022.1 with the metadata mapping from the parts and from the CAD assembly, it means that effectively, if your incoming CAD represents your connectors and that contains metadata on the part level, we can map that part level to the connector. We can independently have controls on how the customers want to model their connectors, and then using Scenario Manager, we can robustly apply those controls to those connectors via that metadata that comes from the part. So this really is kind of a way of bringing all of that information together and making sure you get the right realization on the right connector at the right time. And I think that's more or less the end from my side. And I'll hand over to Greg.
Thanks, Tim. Okay, so as Tim introduced, I'll be going through some of the parts and subsystem updates that have happened for 22.2. And all three of these are interrelated. They're all related to how parts and subsystems interact with include files effectively. And the first piece is part assembly organization. So in 22.2, we have made it so that all part assemblies are created and maintained in the main model. They no longer get organized into include files. So when you open a HM file or import a solver deck, we will organize part assembly files into the main model. So for example, this is what you'll see going forward. All your part assemblies organized in the main model include, whereas previously you could have had them within include files. The reason for this, I will go through. So during solver export, we write part and part assembly comments as an XML comment block to the bottom of an include file. And when we write that part comment block, we write all of the assemblies necessary for a part into each include file to ensure the complete hierarchy of the part is captured. So if you have a model that just has one part in include file 1 and another part in include file 2, and this is your simple hierarchy, and obviously it can get a lot more complicated than this. When I export this model, the part assemblies for each part are written to each of these include files in this XML comment block. So what you can see is technically from a solver deck point of view, we're actually writing assemblies into two different include files. So what we were seeing previously, when you were looking at your model, you would see the part assembly was organized into one of the includes. You wouldn't necessarily, you can't see it that it's in both. So what it was giving was a misleading view of the model organization, because where the part assembly lives in the include doesn't necessarily mean that all of the content of the part assembly also lives there. So we were seeing graphical issues when you would say isolate an include file, that because it has the part assembly in it, it would show all of the part assembly content, even though it didn't actually own part 2, which is down here and was in a different include file. So here we get a erroneous isolate that we're showing this part because the part assembly is there, but the part itself actually lives in a different include. So the change that was made was to keep the part assemblies in main model. Therefore, when you isolate include file 1 or include file 2, what you get exported matches what you get isolated. So the solver deck behavior, the solver deck information now matches the show hide isolate behavior. We can still use part assemblies as a selection method for organizing content. So if you want to grab all of the content of a part assembly and organize it, you can do so. If you pick a part assembly and organize it into a subsystem, we will take the content of the subsystem and we will move just the parts into that include file. I should note at this point, if you do the same thing and you organize a part assembly into an include file, there's this pop-up move to include organization dialog. That will still allow you to select the part assemblies because it's based on references, and so you can trick that one into picking part assemblies and move the part assemblies into an include file. That will be addressed going forwards and is no issue. But what it means is you will get that incorrect isolate behavior that I described before. But what you can do if you do that is you can, again, anytime you save and open your model, the part assemblies will be put back into main model and the correct behavior will be restored. Subsystem hypermesh representations. So for 22.2, we have changed the file format of a subsystem representation file. Previously, when we wrote a representation file, we would create a solver deck file. We now write a hypermesh file. This allows a couple of important additional enhancements in behavior. So it allows for the hypermesh file to contain information that solver decks don't support, such as geometry. It also allows the hypermesh file to contain information for multiple solver profiles at once. Obviously, if you write out an OptDestruct deck, it's only got OptDestruct information in it, whereas a hypermesh file can contain information about Radios and OptDestruct at the same time. So the hypermesh representation allows the subsystem to own multiple solver profile information at the same time, kind of trending towards this kind of engineering modeling philosophy. Any previously saved solver deck representations, either in the library or locally, can be added and can be loaded into hypermesh. That's still supported, but anytime you save a deck going forwards, we will now write a hypermesh file. And one of the reasons the hypermesh binary file is important is for this other new support that we've introduced for .2 is a subsystem hierarchy. So we support a subsystem hierarchy, which is now more tightly integrated with an include hierarchy with a one-to-one mapping of includes to subsystems. So previously, you could have a subsystem that owned multiple includes. So here we've got a seat subsystem that owns technically 4 includes, the seat and its content plus 3 child includes. These 3 includes, you can't easily differentiate the content of these includes from subsystem view. So you were having to toggle, in cases of nested include files, back and forth between include view and subsystem view. With 22.2, what we've done with the support of a hierarchy is we can now support the nested includes as nested subsystems. So now you get 4 different subsystems for 4 different includes, and you can obviously tell each of their content independently from one another, both graphically and within the browser. We have also added a model subsystem. So again, we used to show subsystems for each subsystem you created was related to an include file, but there was never a subsystem for the main model. And so when you were looking from subsystem browser at your model content, you could never see what was left over in main model. So now we have a model folder that contains the same content as the main model include. This comes at the top of the hierarchy and all of the content is listed, and then all of your subsystems are listed after. And in future releases as well, this content will be grouped, so it will be collapsible, so it doesn't always appear at the top of the list, and all your subsystems below it, but will be grouped, so you can kind of collapse it out the way as well. In terms of how this hierarchy now affects representation and revision management, we support representation and revision management at all levels of the hierarchy, with the exception of the model. So the model subsystem can't be saved because the model subsystem owns all of the content of the model, and technically saving the model subsystem is just like saving your HyperMesh file like normal, just doing file save. It's the same, you get the same content. So we support representation and revision management at all of these different hierarchy levels. I'm just showing kind of 2 levels, but we support even deeper nesting scenarios. If you save a representation at this top level of seat, this pink subsystem, it will save all of the content of the seat subsystem plus all of the content of the subsystems beneath it. If you save at the frame level, it will save just the contents of the frame plus if there are any subsystems beneath frame. And again, if you same thing, if you save the content of foam, we save the content of foam independently of mechanism and frame. So you can treat the representation and revision management as though you can revision all of these independently. So if you want to make a change just to the frame, you can do so. If you want to make a change just to the foam, you can do so. You don't require, because you make a change to the foam, to revision all of these different subsystems. So they all can be treated independently, and they can also all be rolled up into this top level subsystem, and that can own all of the revisions and of the whole hierarchy. We've made changes as well related, because of the hierarchy, to the subsystem sets and configurations. When you do a subsystem configuration, we allow you could drag and drop subsystems into a configuration, and you activate the configuration, and that turns on and off subsystem content. We have made it so that anytime you have like a block of subsystems, so like this hierarchy of the seat, you can only move the seat subsystem itself into the configuration. You can't move any of the subsystems below it. And when you activate a configuration, it takes the seat and everything below it, just like it was with the representation. It takes all of the content below it and treats it as one big block. And the reason we turn stuff on and off together is because otherwise what you see in HyperWorks is not what you get when you export a model. So for example, if I was to activate a configuration and treated the seat independently of the subsystems below it, I could, for example, make it so that the seat wasn't written, but the include files below it were exported. Of course, when you run the analysis, these include files are referenced within this include file, and if this include file wasn't exported, these don't get added into the analysis either. So to make it so that what you see in HyperWorks for a configuration is what you actually analyze, all of these subsystem configurations, the whole hierarchy is treated as a big block. If you try and organize a subsystem into a configuration that's not allowed, it will be blocked, and you'll get a pop-up message saying, please only organize top level subsystems. So we take care of that for you. But just something to be aware of when you're trying to do that, about why that's there. And because this has come in 22.2, what about compatibility with 22.1 and 22.0? So opening a previously created model where we have these kind of nested subsystems, we take care of that when you open it in the previous model. We drop all of these subsystem informations and we make it just like we behaved in 22.1 and previous, that the subsystem owns multiple includes. So within the 22 release cycle, any model you now create in 22.2 with the hierarchy is backwards compatible within the 22 release, and we'll just drop these subsystems and wrap it up into one subsystem and multiple includes, just like the previous support was. So with that, that's everything. I thank you for your attention, and if there are any questions for either myself or Tim, please let us know.